All right, so we're going to use the graph to write the system of linear inequalities and identify the solution region. So just like when we were writing systems of equations, or when we were writing singular inequalities in 10.1, we have to write an equation for both boundary lines. So our equation is going to be y equals mx plus b. So we're going to identify the y-intercept for each. And then we're going to identify the slope, which is the rise over run for each. So we're going to identify the y-intercept. So I'm going to go over here on my graph, and I'm going to use a different color. So I'm going to start with this y-intercept right here. We'll call this one line 1. And I'll switch my color, and we'll say this one is line 2. So my y-intercept for line 1 is at positive 5. So b is equal to positive 5 for line 1. And b is equal to positive 4 for line 2. So the line 2 has a y-intercept right below line 1 at 4. So starting with line 1, we're going to go from that point to another point on line 1, which here's another point on line 1, and I count my rise over run. So this is up 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5. So my slope is 5 divided by 5, which 5 divided by 5 is equal to 1. So my slope of equation 1 is going to be 1. 5 over 5, which is equal to 1. All right, now I'm going to choose another point on my blue graph, so line 2. All right, so we have our 2 points for line 2. We're going to calculate our rise over run. So it looks like we go up 1, 2, 3, 4 over 1. So my slope is 4 divided by 1, which 4 divided by 1 is 4. So I have a y-intercept, a b value of 5 for line 1, and a slope or an m value of 1 for line 1. So we have y equals 1x plus 5. That's the equation for the boundary line of line 1. And the equation for boundary line number 2, y equals 4x, because that's the slope, plus a y-intercept of 4. So go ahead and get those two equations written down, and then we'll talk about the shading and what kind of line it is. All right, so once we identify the two equations for each boundary line, we're going to look at the shading and what type of line it is so that we can determine what inequality symbol. So it says the shading is above or below line 1. So we can see that the darker shaded region is below line 1. So it's shaded below line 1. And boundary line 1 is a solid line. So it's shaded below and it's a solid line, which means we're going to use the less than or equal to symbol. So less than or equal to is the inequality symbol we're going to use for line 1. And then for line 2, the shading is above the line for line 2. And it's also a solid line. So instead of being the less than or equal to, we're going to use greater than or equal to. So for line 1, we're going to use the less than or equal to symbol. For line 2, we're going to use the greater than or equal to symbol. So we're going to reuse the same equation, except instead of an equal sign, we're going to use the less than or equal to. So y is less than or equal to 1x plus 5 for line 1. And y is greater than or equal to 4x plus 4 for the second line. So we write the equation, And then we determine the inequality symbol based on whether it's shaded above or below, or whether it's a solid or dotted line. So it says the solution region is the darker part of the graph, which represents the overlap of the graph of the individual inequalities. So the solution region includes the solid rays along the boundary lines. So all of the solutions that are in the darker shaded region and that's on the line, those are the solutions to our inequality. So is the point of intersection of the boundary lines part of the solution? Use the example to help us answer this. So the question is asking us where the lines intersect. So this point right here, go ahead and put that point on your graph. So the point where the two lines touch. So since it's on a solid line, the point of intersection is a solution. So yes, because the lines are solid. So if a point is on the solid line or in the darker shaded region, they're considered solutions. So I'll pick one point that we'll check just to be sure. So let's check the point -3, 0. We're going to check this point -3, 0 to make sure that it is a solution because it's in the darker shaded region. So we're going to check the solution -3, 0. So we're going to use my first inequality. I'm going to plug in the 0 for y and the -3 for x. So 0 is less than or equal to -3 plus 5, and -3 plus 5 is 2. So this is saying that 0 is less than or equal to 2, which is true. 0 is less than 2. And then we're going to substitute the 0 in for the y, the -3 in for the x again. So 0 is less than or equal to -12 plus 4. -12 plus 4 is -8. So this is saying that 0 is greater than or equal to -8, and 0 is greater than -8, so that is true. So if it's true for both inequalities, is it a solution? Yep. So yes, it is a solution. Because we got both inequalities were true. It has to get true for both inequalities to be a solution. So if the point's in the darker shaded region or if it's on the solid line, the point is a solution. So today you're going to be in charge of writing the different inequalities and determining what types of points are solutions.